Hello and welcome to this latest video in the OCR series. In this video we're going to be taking a walking talking mock look at the May and June 2022 paper. This is the paper for Unit 2, Algorithms and Programming. This is the big picture slide for Unit 2. This is exactly what you will need to know when you go into the exam. You'll see there are 5 key topics that you need to look through, and you should find quite a decent amount of revision resources online for each one of these. So the plan is we're going to go through the exam paper and we're going to be looking at how we could get full marks but in as short a way as possible. So really focusing in on the key content and the key answers. It'd be useful if you have a copy of the exam, and at the moment you'll probably need to ask your teacher for one of those because the 2022 paper is still under embargo for another 18 months. And if you get that, you can then attempt each question. I will then go through what I've written and show you a model answer for each question. So hopefully you've got a paper with you, but either way, let's get going. So a nice question to start off with. We've got a tick box, and we've got to tick one box in each row to show whether each example code given is selection or iteration. So whenever we see the words for or while, we know that's looping, that's iteration. If and switch, those are the 2 keywords we'll see for selection. So you need to try and remember those, but you should get an answer that looks like this. Obviously, this is 4 marks for tick boxes, so even if you don't know this one, make sure you take a guess. But for and while will be iteration, if and switch will be selection. We're then asked to write pseudo-code, that's another phrase for OCR reference language, to increment the value held by the variable score by 1. Hopefully this is a fairly straightforward answer. We want to be putting score equals score plus 1. So we take what score was previously set to and we increase that by 1. We're then asked to look at 2 definitions, and this is right at the start of the course if you study in order, looking at the cornerstones of computational thinking. We want to break down a problem into smaller chunks, and we're looking at hiding or removing irrelevant details from a problem to reduce the complexity. So we're thinking, what are those 2 phrases? So breaking a complex program down into smaller problems is decomposition, and hiding or removing irrelevant detail is abstraction. There are only 4: decomposition, abstraction, pattern recognition, and algorithms. Hopefully you've learnt those at the start of the course and can remember those couple of phrases there. We're then looking at a fast food restaurant who offers half-price meals if the customer is a student or has a discount card. The offer is not available on Saturdays. The computer system is used to identify whether the customer can have a half-price meal or not. So we're looking at a logic diagram to take in those variables. We've got A or B and not C. So the key bit here is, can you remember the 3 logic diagram shapes? That's the answer you should be getting. The AND goes at the end. So we put A or B through an OR gate, A and B through an OR gate. I try and teach my students that the OR gate looks like a letter and a capital R has sort of taken a chunk out of the curved edge. Really important, that one has a curved edge. AND gate is easy, that's just a capital D. So remember and then a capital D for that. And the NOT gate is the different one. It's the one that looks different to the rest. So we've got a triangle with a small circle at the end. That's what you should be placing as your answer, and that's the only thing you would get marks for that question. You get 1 mark per logic gate. So again, if you don't remember all of them, have a guess. Make sure you put in the ones that you do know. We're then asked to describe the purpose of a truth table. The key bit here is that this one is 2 marks. So we need to be thinking around exactly what we're going to be saying. We're going to get a mark for saying that we're going to show all of the possible inputs. That's 1 mark, but we need a second one, and you can't just say and all of the outputs. You've got to be along the lines of and all of the associated outputs for a logic circuit, e.g. every input and every set of outputs that might generate. You need to be quite clear there with how you're writing, or you'll be dropping a mark. Next, state how many rows are included in the truth table for this expression. You always do 2 to the power of the number of inputs. Here we've got 3 inputs, A, B, and C. So we're going to do 2 to the power of 3, which is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So again, the only possible answer to that question is the number 8. We're then on to the first of our algorithm questions. When we're talking around algorithms, we can draw a flow diagram or OCR reference language unless they specifically tell us which one to use. Here it does quite clearly say we need to design the algorithm using a flowchart. So the restaurant needs an algorithm to help employees work out if a customer can have a half-price meal or not. It should input the required data, decide if the customer is entitled to a discount, and output the results of the calculation. We've got 2 issues here. Can we make that algorithm? And can we remember the different shapes of the flow diagram symbols? Because the shapes need to be correct. This is another prime example of a flow diagram that you've got to give a go. Because if you put start and then an arrow and you put end, you're getting 1 out of 5. Now hopefully we're aiming way above that, but it's a prime example of somewhere where you've got to give these things a go. We've got our 3 inputs. We've got whether they're a student, whether they've got the discount card, and whether and what day they've come in on. In this example, we've said if the day is not Saturday, head down a false route. If it is, are they a student or have they got a discount card? If no to any of those things, it's output full price. If yes, we want to output half price. Again, you only get the marks for each key sections if you have got the correct shape. You've got 5 marks available, so you want your start and end, your inputs, your couple of decisions, and then the outputs, and each of those things will get you a set of marks. The restaurant adds a service charge to the cost of the meal depending on the number of people. If there are more than 5 people, 5% is added. Customers can also choose to leave a tip. This is optional, and whether customers can choose between a percentage or a set amount. Identify all of the inputs that are required for this change in the algorithm. So we're thinking, what have we not already got that we're having to add because of this change? Here we've got the number of people and whether they want to tip a percentage or a set amount. Now again, this is a 2-mark question, and those are then the sections we're getting. The number of people, is it 5 or more? And then whether they want to tip a percentage or a set amount. We've now got our first real stint of OCR reference language. Now these questions are really useful because later on you're going to have to write your own OCR reference language. And you can think about, can I use this to remind myself of any bits I might have forgotten? So if, for example, you've forgotten how to do a while loop, we've got a lovely example here of that happening. If you've forgotten how to do inputs and outputs, because you've got, it's one of your first exams and you're really panicked, we've got a really prime example there of a question that can help us later on in the exam. That's a top tip. Make sure you use any example questions to help you later on. In this example, all we're actually being asked is to define the term casting and to give the line number where that is happening. Casting is when we convert from one data type to another. So we turn something into a string or a float or an integer. That's happening on line 3. Staff ID equals surname plus STR year. So we're taking the year, which was probably a number, and we're turning that into a string. We're then asked to complete the trace table for the algorithm when the surname Kofi and the year 2021 are entered. You may not need to use all of the rows in the table, and in this example you definitely don't. So we're noting down what the variables are set to at each key point in the program or any time there's a key change. So the program is going to change on line 3. We've entered Kofi and 2001. And we can see that the algorithm on line 3 puts surname and the year after that. So line 3, staff ID is going to set to Kofi 2021. We've then got a while loop that says while staff ID.length is less than 10, add staff ID plus staff ID plus X. Now, go careful there. The X is in speech marks, so this is not a variable of X. It's not the loop count. This is the actual letter X being added to the end. So then on line 5, we're looping through and we're adding X to Kofi 2021. And then we're adding X again because it's all about the length of that phrase. And it's while it's less than 10. So we're working there until the length of the staff ID is 10 or more. We then jump down to line 7 and we've got the output, and the output will also be Kofi 2021 XX. So we've then got a 10-letter output added to this program. So again, with a trace table, you only need to note down where there's a change. If you've put extra rows, you'll still get the marks, but these are the rows that you'll get the 4 marks for. Each complete row will get you 1 mark. There is absolutely always a question in the exam where they give you some data and they ask you to do one of the sorting algorithms on it, a bubble sort, a merge sort, or an insertion sort. This year, they've chosen a merge sort. If I were a betting man, I would say that I think this probably means they won't then do a merge sort in 2023, although I may well be wrong. Okay, so we're looking at completing a merge sort on this data, 45, 12, minus 9900, and so on, and sorting that into the correct order. Now again, your last mark for that should be really simple because you're just putting the numbers in order, but we need to get the marks up to that point. So remember, with a merge sort, we merge each individual number into a pair and we sort them as we do that. We then merge each pair into a group of 4 and we sort them again as we do that. We then merge each 4 into our final answer, and each time we merge, we sort them as we merge them. So you'll see my first line, 12 and 45 are in order, minus 99 and 100 are in order, minus 13 and 0 are in order, minus 27 and 17 are in order. I then merge them into 4s, and again I put them in order, and then I merge those into a group of 8 numbers. So you get, again, a mark for each line there, and you need to be clear that you have merged them in and sorted as you've merged. We're then asked to look at some of the searching algorithms, and we know within our searching we've got a binary search and a linear search that they might ask us about. In this example, they've actually asked us about both of those. Once the numbers are in order, a binary search can be run. Describe the steps in a binary search. Now, whenever I answer questions like this, I like to bullet point my answers. I want to be really clear to the examiner that I'm making 4 or more very distinct points to get me the 4 marks. Okay? So within this one, you can see I've clearly bullet pointed my answer. It doesn't have to be a written paragraph. Other than the essay question in Unit 1, you don't get marks for your spelling, punctuation, and grammar. It finds the midpoint of the list. This is bullet point 2 is something people often forget. It checks whether that midpoint value is the one we're looking for. If not, it checks whether it's higher or lower. If larger, it discards the left half of the list. If not, it discards the right half of the list. It then repeats until that's found. There's a final mark available for saying if the size of the list gets down to 1 and it's still not found, the number obviously doesn't exist. But I've got clearly there 6 valid points, so I've definitely exceeded the 4 marks that I need. It's all about that division of the list, checking the midpoint and dividing more and more and more times. We're then asked to do pretty much the same for a linear search, but a linear search is much more straightforward. Describe the steps a linear search would follow when searching for a number that is not in the given list. We would start with the first value and we'd check every item in turn. Okay, we'd keep checking and keep checking until we got to the end. When we got to the end, we'd know it didn't exist. Again, I could have said that in my answer, but actually I'm aiming for my 2 marks there and I've definitely got those. We've then been given some more OCR reference language, and we've got Jack who's writing a program to add some numbers. Give 2 ways that the maintainability of this program could be improved. The mistake that students make here is to overcomplicate. They look at this question and think, well, we should be using a loop, I should have a while loop or a for loop. That's not strictly maintainability. Maintainability is things like comments, indentation, sensible variable names. Now, there's no if statement here, so there's no point in indenting our answers. So the two we're going to get a mark for is to add comments and to use sensible variable names. Those are the two for improving this maintainability question. Jack's program uses addition, which is a plus. State the purpose of each of the following. We've got the star shape and the /. That's one you're either going to know or not. Hopefully you're aware that a star is multiply and a / is divide. Another fairly nice question now on page 10. We've got a decent length paragraph and we've got some keywords that we can put into those spaces. It's one word per space. It always is unless you're told otherwise. And we're only going to use each word once. So we've got a fairly nice question now at the start of page 10. We've got 5 marks available for filling in the blanks in this paragraph. So we're given a range of information about compilers and interpreters and types of language, and we're asked to fill in each gap. We're given some potential answers. We only use each one once, and we only use one per gap. So Jack writes his program in a high-level language. That's the idea of high-level languages being human-like, things like Python with command words. Low-level languages being things like binary. It crashes when an error is found. You can have stops there as well instead of crashes. So for crashes, you can have crashes or stops. The code will not run until there are no errors. The executable file produced can run without the compiler. So crashes, you could have stops. The others, those are the only correct answers available. We're then moving on to the sort of slightly longer OCR reference language questions. Remember, in part A of the exam, you can only use OCR reference language. In part B of the exam, you can use Python or another high-level language, or you can stick to OCR reference language, as I will be doing. In this one, we want to write an algorithm that asks the users to input the quantity of numbers they want to enter, repeatedly takes in numbers, and then calculates the total and the average of those numbers. This is a model answer. Number equals input how many numbers. That's how many numbers do they want to type in. I've then put for x equals 1 to number. So if they type in 10, I'm going to go from 1 to 10. Temp equals input, enter a number, and then I need to keep track of the total. So my total is going to be total plus temp each time. The next X there is a bit specific to OCR reference language. At the end, it wanted me to print total, and it also wanted me to print total divided by number. That's how I'd work out the mean average of those numbers. So our first big bit of OCR reference language to finish off part A of the assessment, and that would be a model answer that would get you full marks on that question. As the paper then says, we can use in the second half either OCR reference language or Python, a high-level programming language that we've studied. Python is one. If you're in a different school to mine, you might be learning something else. It says we advise you spend 40 minutes on this section. That's entirely up to you. Probably sensible, and certainly don't spend all of your time on the first half. Although this is the OCR reference language question, we'll also get questions on things like SQL and data types, as we are in this first example. State the most appropriate data type for nights and room. It shows us an example, so we know that nights are numbers, and then room is a text-based value. So the answer there is going to be integer and string. I guess the only mistake you could make is thinking that nights might be a decimal value. It definitely shouldn't be. Give the name of the one field that can be stored as a Boolean. Remember that Booleans are true and false values. So answers that can only be true or false. There's only one there, stay complete, and we can see that that is set to false. So stay complete is going to be your answer for that section. Booking records are stored in a database called table bookings, TBL bookings. The following SQL statement is written. Select all from table bookings if nights less than 1. We need to recreate that as an SQL statement that is correct. Select star is going to be your first mark. from table bookings is going to be your second mark. The word where is your third mark, and then nights greater than 1, because in the example they've said less than, is your final mark. Those are going to again be the answers. You could put select and then write all of the column headings instead of star, but it's a bit of a waste of time, so I wouldn't do that. Okay, so that's going to be your answer there again for a nice 4 marks. This is another prime example where you shouldn't just do nothing because you can't answer the whole question. Even if you just put select star, you've got 4 marks. From table bookings in the example is actually correct. So again, we're adding in from table bookings, and again, that works fine. Okay, so 4 marks there for that question. We've then got a fairly lengthy question, and in the real paper, it gives you a lot more space to answer this as well. When a new booking is recorded, details are entered into a program to validate the values. The following criteria are checked. First name and surname cannot be empty. Room has got to be either basic or premium. Nights has got to be between 1 and 5. We might say greater than 0 and less than 6. If it's valid, it's not valid, we need to say not allowed. And if it is valid, we need to say allowed. They've started the algorithm for us, again, giving us a nice example of OCR reference language, and we need to finish it off. So this one is fairly lengthy. It's also an example of a question where there are multiple correct answers. So what I'm showing you is not the only correct answer, but it is the one they recommend within the OCR mark scheme. We want to check if first name equals blank or surname equals blank, set valid to false. If room doesn't equal basic and room doesn't equal premium, set valid to false. If nights are less than 1 or greater than 5, set it to false. And then at the end, check, is that value of valid true or false? Like I say, a bit of a tough one there because there are lots of correct answers, but have a think around whether you're along the right lines there for each key section of code for the marks available. We've then got a basic test plan and asks us to name what type of test data we've got in each case. So we've got normal test data at the start. Boundary would be 1 or 5, and erroneous or invalid would be anything other than 1, 2, 3, 4, 5. Okay, so any other data you put in, I've gone for 20, would work then for the not allowed or erroneous data. Moving on and staying on this sort of theme around this hotel, it wants us to create a function called new price that takes in or has the parameters of the number of nights and the type of room. It should then calculate the price. So this is really around, can you remember how to create functions within your exam paper? Your function should look something like this. Function new price, and then in brackets, nights and room. Those are the 2 variables that we're going to take in. You could call them as other things, but those are probably the sensible names. That first line gets you 1 of the 4 marks. We're then checking if the room is basic, and we're working out the price. Price equals nights times 60. It tells us that it's £60 a night. That's our next mark. Else if room equals premium, and then we're working out the price of nights times 80. You also need to remember that functions return a value. They don't print the answer, but they return a value. So we need to have return price. Right at the end, we put end function, and there we'll be getting our 4 marks out of 4 for that question. That sort of seems quite daunting when you read the question, but actually when you break it down, that's a fairly straightforward question with 2 if statements and then the function definition at the start. We're then asked to write program code that uses new price to output the price of the room. You can do this in one long print statement, print new price, and then inside of our brackets, premium and 5. So I'm passing premium into the function as the room and 5 into the function as the number of nights. I've just noticed when I'm doing that premium and 5 should be the other way round based on my function. So in my function, I've got nights first and room second. So I'd need to make sure that actually my answer should be new price 5 and then premium that way round. We've then got an algorithm and it's asking us to look for some errors. So we've got some code here and it's saying, right, there are 2 problems, and we know there are 2 problems because it says so in bold, but also because we've got the 2 marks available. We're looking at, right, what are these issues? It says that the hotel has got 9 rooms, numbered 0 to 8. So our for loop is incorrect because we're doing for count 1 to 8. So it should be 0 to 8. We've also got our total equals 0 inside of the loop. So total's going to reset every time the loop goes round. So the for loop should be 0 to 8, and total equals 0 should be before the loop starts. Pretty much every exam paper I've seen in the OCR Computer Science series lately finishes with a fairly big, meaty OCR reference language question. Normally 6 marks or more, as this example is, and asking you to combine all of your knowledge from the rest of the exam into a big final answer. For some of you, this will be the difference between a grade 7, an 8 and a 9, so it's really key that you have a really good go at these sorts of questions. For others of you, you might not be able to get full marks on this question, but the 1 or 2 marks you do get might be the difference between a grade 3 and a grade 4. Write an algorithm 2. Take as input the number of hours the user has parked and whether their car is electric or not. That's straightforward. We can all definitely do that. Print, hey, how many hours? Hours equal input. Calculate and output the total price, and then repeat continually until the user enters 0 hours. So, again, a question where there are more than 1 correct answers, but this might be the sort of thing we do. Hours equals 1. While hours doesn't equal 0, then. Okay, and you can't just say greater than 0 because you could enter something like -1 and it should still at least function to a degree. Hours equals input hours, electric equals input, and I've just said enter Y for electric. We've then got our if statement. If electric equals Y, then price equals hours times 2. Else if electric equals N, then price equals price times 4. End if. We've then got our print statement at the end and our end while. So again, this sounds like a very daunting question. But if you break it down to our while loop, our couple of inputs, and then our if statements, you can see how every student should better get a solid 4 out of 6 on this question, even if you don't go on and get the full 6 out of 6. Hopefully that's been a useful walkthrough guide of how the Unit 2 paper looks, particularly with Section A and B in place. Like I say, that's a paper that would score 80 out of 80 on the exam, and obviously that would then be a solid grade 9. All the best in your exams in the summer. If you do have any questions, please post those into the comments section below. Thank you very much for watching.